You're watching the Unit 1 Solving Inequalities notes video. Now, the past few lessons and what you've been working on in class has been solving equations. Now, one thing to keep in mind is that how you solve an equation and how you solve an inequality are pretty much exactly the same. So we are not going to change the process, but the one thing that you are going to notice is different is the symbol that separates the two sides. In an equation, we saw an equal sign. In an inequality, we're going to use inequality signs. And what those signs tell us really is, I think the most important thing about them is what happens at the end. How do we interpret the solution? So a few things that you want to keep in mind. First and foremost, an inequality is a mathematical statement that compares quantities. It has infinitely many solutions, typically. Inequalities are solved the same way as equations. And I like to say this isn't something that you have to do, but I always write the variable on the left of the inequality because it helps me if I ever need to graph it, and I think that it is very beneficial when you're interpreting the solution. One thing that you probably remember from middle school is that when you divide or multiply by a negative, the inequality symbol changes directions. So it will flip. So what I mean by this is if I'm looking at a greater than symbol, it flips to become a less than symbol. And we'll see more of that when we actually look at some examples where this happens. So down below here, you can see the lingo that is associated with equations and inequalities. And a lot of these symbols and notations you probably already know, so I'm not going to spend a great deal of time talking about them, but I do think it's important to just kind of do the Cliff Notes version. So of course, if we are graphing something on a number line that is equal to, it just looks like a dot on a number line. It is equal to, is the same as. We also have a less than symbol and a greater than symbol, and this is what they look like if the variable's on the left-hand side. Okay, that's something very important to remember. And here's some key words. So a less than is less than, is fewer than, the greater than, is more than, exceeds. And then, of course, we also have less than or equal to and greater than or equal to symbols. Now, some people still have trouble remembering which is the less than, which is the greater than. So I encourage you to do this right now. Put your two hands out and make the capital letter L with both your left hand and your right hand. One of them looks like an L, the other one looks like a backwards L. The correct L makes the less than symbol if you kind of turn it a little bit. So the left-hand side will make an L, so that's how you know that it's the less than symbol and not the greater than symbol. Think less than L. Okay, now as we move on, there's a few things down below here. We can use the calculator to check our work. This is very similar to what you did with equations. Right now, I just want you to know that it's here. We'll probably use this more in class when we're checking our work, but don't focus too much on the calculator piece for your video. So exercise 1 says, for each inequality, state whether it is true or false. So we are just going to read these statements, and I'm going to use T or F. So A says, is 7 greater than 2? Yes, that's true. So we're going to put a T. For B, is negative 7 bigger than negative 2? Well, no, it's not. And if we just even use one of the number lines down below to help us, is negative 7 bigger than negative 2? No. So remember, with negatives, we have to think about it almost a little backwards, so that's false. C, is negative 9 less than 5? Sure is, so that's true. How about D, is 5 greater than or equal to negative 8? Well, it's greater than, so that's true. E says, is 10 and 2/10 bigger than 10 and 1/10? Some of you might like to think about this as money, so is $10.20 bigger than $10.10? It sure is. Another true, lots of trues. And then lastly with F, remember they're negative, so it's opposite of what we would think. So many of you would think that negative 4 and 5/10 is bigger, but because it's a negative, that actually means it's more in the negative direction. So is negative 4 and 5/10 less than or equal to negative 4 and 1/10? Yeah, that's true. Now exercise 2 wants us to graph each solution on a number line. So number 1 says m is equal to -3. So that's just a point at -3. Now if we look at number 2, we can see that we've now introduced the inequality. So x is greater than 6 1/10. So I'm going to zoom in just so we can really see what's happening here. Oh, it zoomed out. Let's zoom back in. So first I need to identify whether or not the point is open or closed. Can x equal 6 1/10? And the answer is no. So we are just going to draw an open point, an open circle. And x is greater than, so we have some shading that's involved. Everything to the right, so everything bigger than 6 1/10. And there you have it. That's the inequality graphed. Moving on to 3, this one says b is less than or equal to -9. So you guessed it. I'm going to put a point at -9, and it's closed because it can equal. But I also need to keep in mind that there needs to be some shading involved. Where is b smaller than -9? Well, that's all to the left. Now some of you might remember this trick where you turn it into an arrow. And you can see that these two arrows actually match up. This will only work if the variable's on the left. That's why I emphasize that so much. Now, I guess this is a great question now. We see in question 4 that the variable is not on the left-hand side. So what we should do, and this is what I like to do, is I just like to rewrite it. So instead of 5.5 being greater than y, that just means that y is less than 5 5/10. So let's identify, where is 5.5 on the number line, and is this point open or closed? Well, it cannot equal, y cannot equal 5.5, so that's why we are going to introduce our open point right in between 5 and 6. Mine's a little off. Let me try to see if I can get that a little bit more in the middle. Okay, now y is less than 5.5, so y is smaller than. So where are all the numbers smaller? All these guys over here. Moving on to exercise 3, we actually have a pretty cool task. So what our job is to do is we need to figure out if A, B, C, and D, those values that were given for x, if it makes the inequality that they gave us above true or false. So I want you to take a moment right now to think, okay, what on earth could I possibly do with x is equal to 10 for A? Well, some of you are thinking substitute, 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 substitute. You are so right. So why don't we try doing that? And some of you might have thought of a different strategy, but let's hold off on the other strategy. Some of you might want to solve this inequality. Let's not even worry about solving just yet. So I need to know, is x equal 10 going to make this inequality true? So anytime I see an x, and I'm going to just show my x in a different color, I'm going to put in 10. So 10 minus 2, and then I'll be doing 2 times 10 over here. So the next thing that we need to do is just simplify. So 3 times, well, what is 10 minus 2? Notice how I just used some order of operations to help me simplify that. And I'll do the same thing on the right-hand side. Well, I'm going to multiply before I add, so 2 times 10 is 20 plus 1. And 3 times 8, of course we know, is 24. And is 24 greater than 20 plus 1? 20 plus 1 is 22. Is this a true statement? It is. So what we would write down is that x is equal to 10 is a solution. Okay, it makes it true. So you could say solution / true, but I'm going to write solution and not a solution. Okay, let's do the same thing for B. So you guessed it, we're going to start with that original inequality again, and notice how I'm leaving what I like to call a skeleton. and I'm going to substitute in, we did 10 in A, but now we want to try out x is equal to 3. So let's put 3 into both of those, and we're just going to simplify the same way that we did up above, just with different numbers. So 3 minus 2 is 1. 2 times 3 is 6, plus a 1. So then I end up getting 3 times 1, which is 3. Is 3 greater than or equal to 6 plus 1? 7. Is 3 greater than or equal to 7? No. So this is false, or not a solution. So why don't you take a minute right now, pause the video, and work on C and D on your own, and when you finished answering C and answering D, then unpause the video and check your answers with mine. All right, so here are the answers to C and D. You might want to just pause the video right now. If you made any mistakes or have any questions, make sure you make note of that and ask me in class. As we look at exercise 4, it asks us to consider the true statement 9 is less than 12. So everyone agrees 9 is smaller than 12. Okay, I agree too. So A, what is A saying? If we add 3 to both sides of the inequality, well, what's 9 plus 3? That's 11. And what's 12 plus 3? 15. So we now have a new inequality statement. 11 is less than 15. Is the resulting inequality true or false? This is still true. 11 is smaller than 15. It didn't change anything. Well, if we look at B, what happens if we subtract 3 from both sides? So 9 minus 3 is 6. Is 6 less than 12 minus 3? 9, is 6 smaller than 9? Yeah, that also made a true statement. Okay, let's take a look now at C. If we multiply both sides of the inequality by negative 3, well, I end up getting negative 27 is smaller than negative 36. Is negative 27 smaller than negative 36? No, I would rather owe someone $27 than 36, so this is not true. This is a false statement. Negative 27 is bigger than negative 36. All right, where are they going with this? So we just multiplied by a negative, and it made a false statement. Let's see if we divide both sides of the inequality. And notice how there's a typo. It says inequity. That should say inequality. I think I fixed it in your packet. So what if we divide both sides by negative 3? Well, 9 divided by negative 3. And if you're uncomfortable with working with integers, remember you can always use your calculator to help. That's negative 3. And 12 divided by negative 3 is negative 4. So is negative 3 smaller than negative 4? No. This is also a false statement. Well, let's talk about C and D. We created 2 false statements when we multiplied or divided by a negative. So what is an easy fix? How could we make this statement true? Well, what happens if I just flip the inequality symbol in the other direction? So instead, what if I did negative 27 is bigger than negative 36? Is that a true statement now? Sure is. How about here? Is negative 3 bigger than negative 4? Sure is. So when we divide or multiply by a negative, we have to flip the inequality sign in order to make the inequality statement remain true. So exercise number 5 wants us to solve for each missing variable and then state a value that is a solution to the inequality and one that is not. So things to remember when you solve an inequality, you solve it just like you would in an equation, and just to be mindful of your inequality sign. So if we ever have to divide or multiply both sides of that inequality by a negative number, then we have to flip the inequality symbol. Let's get started. A, what would you do here? Well, regardless of what method you choose, I see some parentheses. So let's distribute the negative 3 to the x and the negative 3 to the negative 1. So I now have negative 3x plus 3, remember a negative times a negative is a positive. Don't forget about the plus 4 is greater than or equal to 6. Now I'm going to choose to use the sorting method. You don't have to, but I like it. So negative 3x stays on the left-hand side because it's a variable. And notice how my plus 3 and plus 4 are both constant, so those will move to the other side of the inequality. So I'll now have negative 3 and negative 4 on the right-hand side of the equation. And of course that plus 6 doesn't change, he just stays there. We can group them together now. So negative 3x is greater than or equal to negative 3, and a negative 4 is negative 7, and a negative 7 plus 6 is a negative 1. All right, so now we are going to divide both sides by a negative. Well, some of you might be thinking, oh my goodness, we divided by a negative, our inequality sign has to change, and you are right. Good job for remembering that. So instead of a greater than or equal to, we're going to change this to a less than or equal to. I will tell you, this is one of the biggest mistakes that I see in inequalities, so just remember to change the inequality symbol to the other direction. So x is less than or equal to, well, a negative 1 divided by a negative 3 is a positive, and I'm actually going to leave this as x is less than or equal to positive 1/3. So let's move on. What is a solution? Well, anything that's smaller than 1/3. So what's smaller than 1/3? I think 0 is smaller than 1/3. I like to use that. And something that is not a solution. So what is not smaller than 1/3? Maybe something that's bigger than 1/3. Maybe 2/3. Maybe 10. Maybe 3,000. Anything that's larger than 1/3. Let's pick 15. All right, moving on to B, we're going to solve this inequality. And as I see here, I have lots of parentheses, so I'm going to distribute actually on both sides of this inequality. So I now have 7/10 C minus 9 times 7/10, which is 6 3/10, is greater than, well, what is 9/10 times 2? Well, I know that 9 times 2 is 18, so we have a decimal now, so this is 1 8/10 C. You can also use your calculator. The same thing, minus 7 2/10. I also would like to use a sorting method here. You do not have to, but let's do this in the video together, just so we get a little bit of practice with this newer strategy. So the 7/10 C has a variable, that stays. Now the negative 6 3/10 does not, so that goes to the other side and becomes positive. The same thing happens with my 1 8/10 C. It's positive on the right side, so it moves to the left side and becomes negative. And my negative 7 2/10 stays the same. Now what I'm going to do is group both sides together. So 7/10 minus 1 8/10 is negative 1 1/10 C. And that's greater than 6 3/10 minus 7 2/10, which is negative 9/10. And lastly, we need to get C alone, so I'm going to get rid of multiplying by 1 1/10 by doing the opposite, dividing both sides by negative 1 1/10. And some of you are probably shouting again, I know what to do, I know what to do, I have to change the inequality sign. And you are right, because we divided both sides by a negative again. So because this is a negative 1 1/10 and this is a negative 1 1/10, of course we would use the same number, but because this number here in pinkish red is a negative, the inequality sign has changed. So our final answer will be C is less than, and if you type this in your calculator, you're going to see that it looks like 0.8181818182. Well, we know that our calculator is just rounding for us, so I'm going to leave this as a decimal. I could convert it to a fraction, but I'm not going to bother doing that. I'm just going to leave this as 81/100ths repeating. So moving on, we need to determine something that is a solution and that is not a solution. Remember, with an inequality, there's endless possibilities. So what number, so C, what makes C true? Would 8 1/10 repeating make this true? No, it's any number that's smaller than that. So last time we picked 0 because it was a fraction as well, or part of a number. But let's do maybe a negative number this time. We could do negative, let's go crazy and make it a decimal, negative 9 5/10. This could be anything, negative 1,000, negative 3,562,381, okay, anything. Same thing with not a solution. So what is not a solution? What would make this false? Well, C would actually have to be bigger than 81/100ths repeating, or even equal to. Let's actually pick this, because this is a very significant misconception. A lot of people think that because you see a number there, that means it's the solution. In this case, 81/100ths repeating is actually not a solution because C has to be smaller than that. All right, so our last and final question of this lesson. So we see that there's fractions everywhere. We have to solve this inequality. So many of you might be thinking, oh, I need to find a common denominator. So what number is common to 4, 2, and 4? Well, what can 4, 2, and 4 all divide evenly into? Some of you might say the number 8 or 16. I'm going to pick the number 4 because it's the smallest one, but really we could use any number that 4 and 2 can divide into. So I will multiply this whole side by 4 and this whole side by 4. So remember, we can cross divide, so 4 divides into 4. So 4 divides into 4, creates the number 1. So that would just be 1 times x plus 1. And then how many times does 2 divide into 4? Well, twice. So 2 is left over. So 2 times negative 1. Or you might want to just do 2 times positive 1 with the minus sign out in front is less than, let's divide, 4 divided by 4 is 1, so I'm left with 1, and really 1 times 3 is just 3. And now I can keep simplifying. So some of you might say, well, 1 times x plus 1 is just itself. You're right. And then 2 times 1 is 2, should be less than 3. And let's group our like terms together. So I have x, I have plus 1 and minus 2, so that would become minus 1. Remember to use your calculator if you're unsure of your integers at this point in the game. And we haven't done inverse operations, so let's add 1 to both sides to get x is less than 4 as our final answer. Of course, we want to answer the questions down below. What is a solution and what is not a solution? So a solution would be anything smaller than 4. So 3, 2, 1, 0, negative 572.4. It doesn't really matter. Let's use that fun example. Negative 572 and 4/10. And not a solution would be anything that is larger than 4. So what's larger than 4? 5, 10. 15. Let's pick 15. Also remember that 4 is not a solution because 4 is not smaller than 4. It has to make the statement true. All right, you did it. Nice work.